Scientists just figured out how to make iron from Martian dirt. This changes everything for space colonization. Building a city on Mars has always been impossible because shipping materials from Earth costs over $100,000 per kilogram. But now we can make steel, tools, and entire buildings using nothing but the red soil beneath our feet on Mars. This isn't theoretical anymore. Researchers have already done it in the lab, producing pure iron at 1,000 degrees Celsius using 3 different methods. Today, we're breaking down exactly how they did it, which teams made the breakthrough, and what this means for SpaceX's plan to build a 1-million-person city on Mars. Let's dive in. So how exactly are scientists turning Martian dirt into metal? The secret lies in the composition of the Martian regolith. It's packed with iron oxides, which give the planet its signature red color. Think of it as rust, but on a planetary scale. The challenge is to separate the iron from the oxygen it's bonded to. To do that, you need a chemical process called reduction, and scientists are exploring several ingenious ways to achieve this on Mars. One of the most promising methods is called carbothermic reduction. It's a process we've used on Earth for centuries to make steel. In simple terms, you heat the iron oxide with a source of carbon. The carbon acts as a reducing agent, stealing the oxygen from the iron and leaving behind pure metal. On Mars, the carbon can be sourced directly from the atmosphere, which is about 95% carbon dioxide. A team of researchers from Swinburne University and CSIRO in Australia recently demonstrated this process with incredible success. They used a regolith simulant that mimics the soil found at the Gale crater on Mars and heated it in a chamber that simulated Martian conditions. At around 1,000 degrees Celsius, they were able to produce pure iron. At higher temperatures, around 400 degrees, they created a liquid iron silicon alloy that could be easily separated from the slag, just like in a terrestrial foundry. Another exciting technique is hydrogen reduction. This method uses hydrogen gas to strip the oxygen from the iron oxide. The great thing about this process is that the only byproduct is water, which is an incredibly valuable resource on Mars. The hydrogen could be produced by splitting water found on Mars, creating a closed-loop system. NASA has been exploring this method through its Mars Aqueous Processing System, or MAPS. This innovative system not only produces metallic iron, but also a whole suite of other useful materials like aluminum oxide, magnesium oxide, and silica. It's like a one-stop shop for all your Martian construction needs. But what if we could get even more creative? What if we could use life itself to mine for metals on Mars? That's the idea behind microbial iron extraction. Scientists have discovered that certain bacteria, like Shionella oneidensis, can actually breathe iron oxides, reducing them to a form that can be easily extracted. This process, known as biomining, is already being explored on Earth, and it could be a game-changer for space colonization. A 2021 study showed that using this bacterial process resulted in a nearly 6-fold increase in the amount of iron extracted from regolith simulants. What's more, the resulting material was 400% stronger. This opens up the possibility of using self-reproducing bacteria to create a sustainable and efficient way to produce high-strength construction materials on Mars. From ancient earthly techniques to cutting-edge biotechnology, scientists are developing a diverse toolkit for forging a new industrial revolution on Mars. But what does this all mean for the dream of a permanent human settlement on the Red Planet? Let's explore the implications. The ability to produce iron on Mars isn't just a scientific curiosity, it's the key that could unlock the door to a permanent human presence on the Red Planet. For the first time, the dream of a self-sustaining Martian city feels within our grasp. Let's break down what this really means for the future of space colonization. First and foremost, it's about the economics. As we mentioned earlier, launching anything from Earth to Mars is incredibly expensive. We're talking about a price tag of over $100,000 per kilogram. A single brick by the time it reaches Mars would cost more than a luxury car. Now imagine building an entire city out of those bricks. The cost would be astronomical. But with in-situ resource utilization, or ISRU, we can flip the script. By using the resources already on Mars, we can dramatically reduce the cost of building a colony. For every 1 kg of iron produced on Mars, we save over 7.5 kg of launch mass from Earth. And it's not just about the cost, it's about the sheer scale of the undertaking. SpaceX's vision for a Martian city involves transporting over 1 million people and millions of tons of cargo. That would require thousands of Starship launches over many years, but if we can produce the building materials on Mars, we can free up that precious cargo space for other critical supplies, like scientific equipment, life support systems, and of course the colonists themselves. So what would we build with all this Martian iron? The possibilities are endless. The first priority would be to construct habitats to protect the colonists from the harsh Martian environment. These could be 3D printed structures made from a mixture of Martian regolith and iron fibers, creating strong radiation shielding domes. We could also build the connecting tunnels, creating a network of pressurized corridors that would allow colonists to move freely between different parts of the city without needing to wear a spacesuit. We could also build the connecting tunnels, creating a network of pressurized corridors that would allow colonists to move freely between different parts of the city without needing to wear a spacesuit. But it doesn't stop there. With a steady supply of locally produced iron and steel, we could build the entire infrastructure of a modern city. We're talking about landing pads for rockets, roads for rovers, and even the factories themselves that would produce more advanced goods. We could manufacture the tools and machinery needed for mining, construction, and agriculture. We could even build the very greenhouses that would grow the food to feed the colonists. This is the essence of a self-sustaining colony. It's not just about surviving on Mars, it's about thriving. It's about creating a new branch of human civilization, one that is not entirely dependent on Earth for its survival. And the ability to produce our own metals is a critical step in that direction. So, what does this mean for the timeline of Mars colonization? Both NASA and SpaceX have ambitious plans to send humans to Mars in the coming decades. SpaceX is targeting the first uncrewed Starship missions to Mars as early as 2026, with the first human missions to follow. While these initial missions will still rely heavily on materials from Earth, the ability to produce iron on Mars will accelerate the development of a permanent settlement. It could mean the difference between a small research outpost and a bustling city within our lifetime. The ability to produce iron is just the beginning. The real revolution will come when we can create a full-fledged industrial ecosystem on Mars. This means not just producing raw iron, but also processing it into steel and other alloys, and then using those materials to manufacture a wide range of products. We could create everything from simple tools and replacement parts to complex machinery and even the structural components of future spacecraft for missions deeper into the solar system. This would transform Mars from a remote outpost into a vital hub of interplanetary commerce and exploration, a place where new technologies are developed and new frontiers are opened. We stand at a pivotal moment in human history. The dream of becoming a multiplanetary species is no longer confined to the pages of science fiction. It is being actively pursued by the brightest minds of our time. The recent breakthroughs in Martian iron production are a testament to this incredible journey. We have seen how scientists are using everything from ancient metallurgical techniques to futuristic biotechnology to unlock the resources of another world. We have explored the profound implications of this discovery, from the economic and logistical advantages to the very real possibility of building a self-sustaining city on Mars. This is not just about building a new home for humanity. It's about pushing the boundaries of what is possible, about inspiring the next generation of scientists, engineers, and explorers to dream big and reach for the stars. The challenges that lie ahead are immense. We still have much to learn about the Martian environment, and the engineering hurdles are significant. But with every new discovery, with every successful experiment, we are one step closer to our goal. The journey to Mars will be a long and arduous one, but it is a journey we must take. For the future of humanity may not be written in the stars, but forged in the fires of a new world. What do you think about this incredible breakthrough? What are your hopes and fears for the future of space colonization? Let us know in the comments below. And if you enjoyed this journey to the Red Planet, don't forget to like, subscribe, and hit that notification bell for more deep dives into the future of space exploration. Until next time, keep looking up.